Notebook 42, Structured Output with Pydantic. In this notebook, we're going to drastically upgrade our ability to generate structured output through a combination of Pydantic classes and LangChain's JSON output parser, both of which we'll be looking at in detail further down the notebook. By the time you complete this notebook, you'll understand some of the limitations of the naive approach we took to generating structured output in the previous notebook. And you'll also learn to create class-driven schemas for structured data generation using Pydantic. To begin, we'll make some imports here. Most of these you'll be familiar with, but new to this particular notebook from LangChain Core and from Pydantic v1, we're going to be importing base model and field. We'll look at the use of these further in the notebook. I'd also like to point out that there have been, or I have seen in my programming, some warnings about the Pydantic v1 module being moved to a different location in the LangChain packaging schemas. So just be aware at the time, if you're downloading fresh and newer copies of LangChain compared to what we're using in this course, you might find that the location of Pydantic base model and field have changed slightly. We will create, per usual, an LLM instance here with no changes. Okay, so let's talk about some limitations of our current structured data approach. Your implementation might be slightly different, and the printout that we're going to demo below might be slightly different than what you had in the previous notebook. But in the solution to the previous notebook, we had some pretty good success actually with the following prompt template, where we iteratively arrived at a solution to get a very specific JSON structure. Using this template, and again, yours might have been slightly different, but we got the following list of book details, which was good, right? Syntactically, it worked. It was an actual Python list with actual Python or with actual JSON dictionaries. And but if we look at it more carefully, it does have some issues. So, for example, the key names are not all consistent for all of the values, right? For example, in this one, we have a year of publication here. Whereas in the second item, we have year, whereas in the third item, we have year published in camel case, right? We have a publication year down here, right? The year has been generated at times as a string. Like for example, here we have a 1992, which is accurate, but elsewhere we have integer values, which is 1965 and 1984, right? So that's inconsistent. There are some places, for example, where the large language model, for whatever reason, didn't feel like it was able to generate the information requested of it, and we got none types, which may or may not have been what we were intending, right? So, that said, at this point in the workshop, knowing what you already do, you're probably already full of ideas, right, about how to address each one of these. And perhaps some of the following ideas come to mind. You could be more specific in our prompt about the names of the keys, the types of the values, and what to do when the LLM can't generate data for a field, right? You could try including a system message to more strongly reinforce how we want the LLM to generate responses. You could provide few-shot examples to help the model understand all the specifics of what it should and shouldn't do. And if you are thinking along these lines, that's really fantastic, and you're definitely correct about approaching the problem this way. However, we can imagine, right, that this could get even more complicated really, really quickly. For example, what if we wanted to templatize more of the prompt? For example, which fields to include? What if our data structure gets far more complicated with additional fields or even nested data structures inside of the data structures? And furthermore, like since we're generating data, what if we wanted to capture a definition of our data type for use elsewhere, right? Not just contained in the prompt, right? But in actual firm data structure definition, as we might do in other source code locations. So again, knowing what you already know, you can likely think of legitimately viable ways to accomplish each of these tasks, even if it seems a little harrowing, and that's good. However, lucky for us, LangChain ships with a variety of tools that can help us accomplish generating structured data in just the ways we're talking about. And as you'll see, there's a slight learning curve about doing it, but once you learn how to do it, it's going to allow them to greatly simplify our application code, get all of the things we're looking for and a lot more, and allow us to create data structures consistently that are a lot more complex when needed. Okay, so to kind of ease our way into this process, even before we look at LangChain specific tools to help us generate structured data, let's take a step back and think about how we might articulate a data structure in Python, right? If we weren't working in the context of LLMs. So one very sensible approach would be to create a Python class. So kind of staying within our example workflow of book details, let's imagine that we were going to define a class representing a given book. We could put a doc string about what it's supposed to do. In the init method, we would pass in the fields that we wanted populated, a title, an author, a year of publication, and we could specify those here in the class. Now, this is reasonable, right? However, there's some of the details that we just discussed about our structured data that this class doesn't yet capture. Like, for example, the intended type of each value. And also, unlike our actual prompt template, there's no description aside from its name, right? Class, book, about what each field ought to contain, or title, or author, or year of publication. So just with that in mind, let's improve on this slightly by rewriting the class to include Python type hints, right? As well as some comments articulated the intended value of each field. So again, we know from this doc string, we want information about a book. And using Python type hints, we can say that title is intended to be a string, author is intended to be a string, year of publication is intended to be an int. And then, again, we're just kind of playing around with the idea here, but we'll include some comments, right? This is intended to be the title of the book, the author of the book, the year the book was published, all right? So it's still missing some aspects like default values, right? If we don't actually have a value, what do we want the default to be? It's still missing things like enforced data validation. We're using type hints, right? But there's no actual enforcement around that. But for the most part, if we had a way somehow, right, to convey the information contained in the class that we've defined here, including the comments, including the type hints, if we had a way to convey this information elegantly to the large language model about this being the structure that we wanted it to generate, then we can imagine we would probably be in pretty good shape. All right, so keep that in mind as we move forward. That's kind of what we're moving towards in actuality. Okay, so we're gonna introduce something called Pydantic. If you've never heard about it, Pydantic, which you can link to and check out more here, according to their own website, is the most widely used data validation library for Python. And if you're not using Pydantic, in any object-oriented Python code that you're writing, there's actually a good chance that you would really enjoy learning how to use it. Like I said, there's a slight learning curve, but it's very, very popular. There's a reason why it's incredibly popular and so widely used. So even outside the context of what we're doing here today, if you're not familiar with Python and you ever write any serious object-oriented code in Python, I highly recommend you check out Pydantic and learn how to use it. We say here that LangChain actually does provide us with exactly what we need to convey the information contained in classes to prompts. And in doing so, we have a really powerful tool that's going to enable us to articulate the structure of the data we want generated in a class, and then let LangChain do some of the more tedious work of prompt engineering for us, right, under the hood based on the class we give it. But in order to do that, we can't use vanilla Python classes. Instead, we need to use Pydantic classes. All right, so for our purposes, we're only going to be using Pydantic to construct straightforward classes so that LangChain can then work with our class definitions to create prompts for us that will assist us in generated structured data. As we imported above, and which I commented on, the relevant Pydantic functionality has been integrated into LangChain. So to begin working with Pydantic classes, we need to make the following imports. I mentioned this above, I'll mention it again. I have reason to believe that in the near future, the location of this might change. So if you find yourself using LangChain and looking to do these imports and in your own environment with a newer version, you get some warnings, just pay attention to them. It'll be straightforward to figure out what they're talking about and where to import these in a different way, if that is in fact, as I suspect, needed. Okay, so there's two things that we're importing from the Pydantic that's integrated into LangChain. One is called base model and one is called field. Having imported them, we're now able to rewrite our book class using Pydantic as follows. So here's the class definition here. As you can see, when we want to construct a class using Pydantic, we create a class that inherits from base model, right? This is the syntax to inherit from another class, to pass it into the class definition as an argument. And that's what we're doing here. And then when we inherit from base model using Pydantic's base model, instead of creating an init function as we would do in a vanilla Python class, we can supply the class's fields at the top level of the class definition by defining them with the field function that we imported up here. And as a convenience, it allows us to provide the named argument description that will allow us to articulate outside of a comment the intended use of the field. Okay, so if we look at it, it's really quite straightforward. It's a little bit different than a vanilla Python class, but all we do is we define the class and inherit from base model. We can, and more on this later, should supply a doc string about the intended use of the class. And then for each of the properties we want, instead of putting them in an init method, we just define them top level. We still use type hints, and then we set them equal to an instance of this field that we imported. And furthermore, we use the named argument description, much as we did with our comments above, to say, for example, title is intended to be the title of the book. Author is intended to be the author of the book. Year of publication is intended to be the year the book was published. All right. Okay, so again, the idea, right, that we're at right now is we've captured, right, the structure of the data we want in this class definition. And now somehow, right, which we're going to explore presently, we would like to be able to convey the information encapsulated in this class definition to the large language model, right, in the form of a prompt that would result in the LLM generating output that adhered to the explicit structure of our class definition. So now let's talk about going from that class definition to what we'll call formatting instructions, right, a prompt. Instructions that will indicate to the large language model how the data ought to be formatted, how it ought to be structured. Okay, so in order to take the structure defined in our Pydantic book class and generate a JSON object, we need a prompt, right, to provide the model. And LangChain's JSON output parser, this is not the same as the simple JSON parser that we used in the previous notebooks. LangChain's JSON output parser is going to provide us with just that. So to begin with, we did this above, but we'll do it again here for clarity. We're going to import from our output parsers JSON output parser, okay? And just like with the str output parser and the simple JSON output parsers that we used previously, we need to create an instance of this output parser in order to use the parser in our chain. Different, however, from the parsers we worked with earlier. We had mentioned that you could pass them additional arguments for more complicated workflows, which we didn't do. But in this situation, we can and will provide JSON output parser with an argument, namely a named argument called Pydantic object. And we are going to specify Pydantic object to be equal to a Pydantic object or a class definition that we've already defined that expresses how we want the JSON to be parsed. So in this situation, we're going to create an instance of JSON output parser called parser, and we're going to pass in the JSON output parser constructor a named Pydantic object argument, and we're going to pass in our book, our Pydantic class definition book, to be equal to the Pydantic object. Okay, now we have parser, and instances of JSON output parser, like parser, contain a method. The method is called getFormatInstructions, and this method will help us create explicit instructions for formatting the JSON based on the provided Pydantic class. So let's take a look at that. So we're going to invoke the getFormatInstructions method on our parser instance. And then if we take a look at it, you can see